All right, today we will be completing the square. To solve a quadratic equation, one of the ways you can do that is using the square root property, which is basically taking the square root of both sides of the equation. And don't forget to take into account the positive and negative square root. So let's look at some examples. Alright, so in order to use the square root property on this, I want to get this x squared by itself. So I'm going to subtract 12 from both sides. And I get, this is supposed to be 42. Alright, subtract 12 from both sides, and I get 30 here. Then, since this is being multiplied, I need to do the opposite, which is divide. And I get x squared equals 15. Now, since x squared is by itself, I can take the square root of both sides of the equation, and I get x equals positive or negative square root 15. All right, next example here, we have x squared minus 10x plus 25 equals 16. So if you look deeper at this and we factor it like we were the other day, we need two numbers that can add together to get a positive 20, two numbers that multiply together to get a positive 25 and add together to get a negative 10. So I know both has to be negative. They're going to add together to make a negative, but multiply together to make a positive. So I could do 25 and 1. I could do 5 and 5. And when I add them, since both of these are negative, I get a negative 26 here. I'm looking for a negative 10, so that's not it. And I get a negative 10 here. So it has to be negative 5 and negative 5. So now I have something being squared on this side. I take the square root of that. And I get x minus 5 equals a positive or a negative 4. So I want to find what the answer is going to be in both scenarios. What if x minus 5 is positive 4? And what if x minus 5 is negative 4? So x can equal 9. X can equal 1. So my answers are 1 and 9. You can add a term to an expression in the form x squared plus bx to make a perfect square trinomial. That's called completing the square. So if you have x squared plus bx, then you add b over 2 squared. So in this example, x squared plus 4x, the b would be the 4 here. B would be the 4. So you're going to add 4 over 2 squared. So 4 divided by 2 is 2. 2 squared is 4. And you would be making the new expression that ends up being a perfect square of x plus 2 squared. Let's look at some more examples here. Alright, so we have x squared minus 8x and x squared plus 11x. So remember, we're looking for b over 2 squared. In this case, our b is negative 8 over 2 squared over 2 squared. Negative 8 over 2 is negative 4. We still have that squared there. And negative 4 squared is 16. So to complete the square, this is what I'd have to do. X squared minus 8x plus 16. And that would be the same as x minus 4 times x minus 4, or x minus 4 squared. Alright, same thing over here. Our b is 11. 11 over 2 squared. Well, when we have a fraction and we can't simplify that and make it a whole number, Then we square the top and we square the bottom. So 11 squared is 121. 2 squared is 4. So we need to add 121 over 4. And this would be the same as x plus 11 over 2 squared. If you would like more practice, you can go to IXL Algebra 2, and the section you want to focus on is K9.